All right, I'm going to go ahead and get started. I'm going to be talking about automating schema migration changes using Ghost. If you've been to the Ghost talks, either in Amsterdam or here previously, they were talking, specifically about Ghost, and we'll talk about that a little bit. But mostly, this is kind of the automations that we use around Ghost. A little bit of a story about project I was working on, things like that, and we'll get into it here. I'm Tom Krouper on Twitter, Captain Eyesight. If you see me walking around with a cane, you might get that joke. On GitHub, Tom Krouper. So actually related to the Captain Eyesight thing, if you have a question, just call out. I'm not going to see you raising your hand. So I'm part of the database infrastructure engineering team at GitHub. GitHub, we have MySQL. Let's see here. I actually stole this slide, so I kind of have to read it. Let's see here. Yeah, so we, of course, GitHub, we use Git, and that's our main data store. But all the metadata, everything around on GitHub, on the website, things like that, MySQL. We have some Elasticsearch and Redis also, but really our main data is MySQL. Yeah, so you can read all this if you want. I'll put the slides up onto the Percona website after this. Okay, so first part of the story we need to talk about is Ghost. If you've been to the previous Ghost talks, a lot of this is going to be a repeat. So a year and a half ago, we were in a team meeting, and we were dealing with some issues with PT Online schema change, where we had some tables that just they couldn't run. We would start PT Online schema change. Some threshold would hit. We would have to either break out, or it would break out because it hit the critical settings or whatever. There were other ones that we could run on the weekends, and we would just cross our fingers and hope that by Monday they would be done and everything would be great. So we kind of had this conversation. It's like, well, what can we do about this? What can we do with PT Online schema change? And really, what's the problem? What are we running into? We kind of came to the conclusion that the triggers that PT Online schema change creates were kind of at the root of the problem. So we had this discussion. Can we do something with not using triggers? And we decided, okay, well, maybe we could use the binary logs instead of triggers. And Shlomi here is like, yeah, no, can't be done. There's no way. I tried it back when I was working on the Oak online schema change, and it wouldn't work. The difference between then and now is we have row-based replication. And so after some iterations and some conversations, we said, yeah, we can probably make this work. So we there we go. So then we came up with Ghost. So I'm going to take a couple minutes to explain what Ghost does for those of you who haven't been to the other talks. It'll be relatively fast. I recommend finding previous presentations online if you really want to get more detail. But the long and the short of it is what Ghost does is it connects to a replica. And this is this replica here over here. It connects to the replica and acts like a replica of that replica, and it's taking in the bin logs. In addition to that, it's running through. It's doing it's taking chunks at a time of the table that you're wanting to change. Saying, okay, I need the first 100 records, put it up to the master, and it's going to write out to what we call a ghost table, which is the copy of the table that's been altered. And then in addition, it's looking at the binary logs and saying anything that is for that particular table, I also need to write to that ghost table. So we have a few, I have kind of an example here of the settings used. Obviously, you need the database, the table, the alter that you're going to do. Obviously can be a lot more complicated than engine equals NODB. The max load, what that's telling you is that if we hit threads running 25, throttle, stop for a minute, wait for things to settle down. With the critical load, it's saying if we hit 1,000 running threads, exit out, get out. Let's see, anything other there that's... so we have this throttle HTTP and throttle control replicas. These are a couple different ways that we can basically test on replication to make sure that like the replicas are not lagging. And if they are lagging, we throttle again and wait until things catch up. So yeah, and the other settings, I mean, they're either mostly self-explanatory, or if you go to the documentation, you can absolutely figure out what's going on there. The next thing I'm going to mention before we get into the kind of the meat of things is the migrations we're doing at GitHub are with Rails. And if you're familiar with Rails, they have, or if you're not, I guess I'll explain it, is what they do is you do like a Rails migrate or something, and what it does is it creates a table or a file for you, and in that file you put the changes that you want for your schema. I think I have it. Yep. So in this example, I'm just have an existing table, and I'm adding this some ID to the example table. And the up-down thing means is if you're moving forward in the migration, you would add the column, and if you had to move back for some reason, you'd use the down. So, in addition to alters, this does create tables, drop tables, so all those kind of things. Then the last part of this is Hubot. If you're not familiar with Hubot, it is a tool that we wrote that is used for kind of a buzzword these days is ChatOps. It basically allows us to run a lot of the commands that we want via chat. We use Slack right now. It works on pretty much any other thing, any other chat application you might have. There's ways to get Hubot to work. So here's some examples. A lot of things that I'll be talking about. The migration command has everything to do with our migrations and how we automate them. MySQL is obviously for all our MySQL tools. We can we use this for doing things like renaming tables. If in the cases of dropping a table, we don't really drop a table. We rename it. That way, if for some reason someone forgot to remove some code or something, that we can just rename the table back and everything will be happy again. We use it for checking the replication stream on our systems, things like that. The QMTD, queue me to deploy. That is the tooling that we use to get into the queue to do a deployment for our systems. And the queue for GitHub is just, hey, who else is trying to do stuff? And then deploy, obviously. Nagios commands, extra backup commands. MySQL proxy is our HA proxy solution. We have all kinds of commands for that. When you're in San Francisco, very important one is truck me. So at lunchtime, you know where the food trucks are. And then where is if you're not sure where someone is, since we're global and a lot of people are remote, you can do where is on a person and say, oh, okay, well, they're in Australia. They're probably not awake. Okay. All right, so on to automating everything. Well, that was kind of the plan, at least, for this talk. I was when I put in this proposal, I was starting on a project that was going to automate all the things for our migrations. It was going to be like a 1 or 2 step process. Well, it was a little ambitious and ran into several roadblocks. And so I'll be talking about some of those roadblocks. First, what I'll do is I'll kind of explain, what we're doing now, what we can do, right immediately to improve that, and then, some ideas of what we're going to be doing in the future. I might just be going back over here. Let's see here. All right, so the first part of a schema migration is a pull request. And like I showed in the in the Rails slide, pull request is going to have something like this in it. There are times where we will, there's obviously going to be code associated with that. If you're adding a column, it's being added for a reason, or if you're dropping an index or whatever, you're dropping it for a reason. But what you need to do, or what we need to do, is have the migration as its own pull request. We don't want to have code associated with it because there's not going to be this autonomous alter table or whatever, and then the code can work magically. Any kind of migration that we make is going to be backwards compatible and in such a way that we are not going to end up hurting ourselves by doing an alter table that would break code somewhere else. Or that's the idea, at least. So one of the ways that we do that is we use this ChatOps command called migration queue. What this does is this, once someone makes a pull request, they say, okay, I want to get into the queue. I want this alter done. It's ready to go. We are ready to go. We want to do everything. There's some commands down here that I'll get into detail a little bit more, but the show, add, schedule, and then completed are kind of self-explanatory. With the show, we want to see, what other migrations are that need to be done. Adding one, obviously. Scheduling means it's ready to go, things like that. So the first step with that is you have, basically with GitHub, you have the ability to set up your repositories to require an approval. So once someone has done their migration, someone's looked at it, usually it's our platform data team who have a really good understanding of the data side of the database and what to look for on that side of things. So they'll approve it, which is great. Now, when I was looking at this this command, I noticed at the bottom here there's an option to shop. So if you can absolutely buy one of these GitHub mugs from shop.github.com. So, sorry. I saw that and I couldn't pass it up. I just thought it was so kind of strange that we had the shop option at the bottom of there. So, anyhow. I wanted to show the migration queue show command. This is basically showing, okay, this top one, someone needs to look at it before it's going to get migrated. The reviewed ones, those are all ready for DBA to process. And then the scheduled one, this is kind of a misnomer because right now, once it's scheduled, almost immediately someone starts to run it. That way, so this should actually probably be saying running or running very soon. The add command, in this particular case, this would be getting something into the needs a reviewed spot. So it's going to say that, okay, this particular migration is ready to go. Someone in the database team needs to do the migration. So once someone does the actual migration queue schedule, this pops up both in chat and it also gets copied to the GitHub ticket. This allows us to, if you're ready to go right away, you can just copy and paste the commands and you will be able to run the migration. This gh-migrate-gh-ost, this is just a shell script. I'll talk about it here in just a little bit. And then I mentioned a little bit earlier the migration complete. This says this migration is done. That long number with the 2017-0413, if you're familiar with Rails migrations, that's that prefix number that you see on the migrations. Let's see here. Now, with the migrations, and we're talking about gh-ost here, the create and drop tables are, gh-ost doesn't know what to do with those. It's not a process that it's used. But in our migration tooling, what we can do is we can have the tooling tell us, okay, well, you have a create table. Well, here's the create table, run the create table. With the drop table, it gives you the command that says, I was talking about MySQL and the dummy drop command. I don't know if I mentioned it as dummy drop, but what it does is it does the rename table. And so it just tells you this is how you do it. In that particular case, if you do have a drop table and that's the only migration, after that you would do the migration queue scheduled and you'd be on your way. So with the alters, it does use gh-ost, and it uses this gh-migrate gh-ost command like we saw before. Let's see here. All right, I guess I'll just stand here. All right. And what it does, what the gh-migrate gh-ost command does is it runs a full listing of gh-ost. So like I showed before, we have a config file, and that has the user and password information. The host is the gh-ost replica. This is not the master. This is the replica that you're looking at. And the database and table, DDL is obvious. I already went through the max load and critical loads and the throttling a little bit. The max milliseconds, that's for the seconds behind master checks, things like that. The switch to RBR, gh-ost requires that you have row-based replication on the replica. If you have statement-based everywhere else, you just have to have one replica kind of hanging off the end that's row-based that can be used for the migrations. The timestamp old table is a new feature. We were running into issues where if you migrated a table and then you needed to make another change immediately afterwards, if you didn't delete that the first iteration of your migration table, it would die. The migration would fail because that table was in the way. So once you get going, once you kick off the gh-ost migration, there's several commands that you can do online that allow you to check up on what's going on. For the most part, gh-ost is just going to run on its own. It's going to throttle itself when there's extra load. It's going to, it's going to fail out if things just go way south. It does an excellent job of making sure that the migration is going to have as minimum impact as possible. However, there are times you want to kind of see where things are, how things are going. So you have all these commands that allow you to check up on the migration. Migration sup command is that gives you really bare bones information. It says, okay, you got this many records that have copied, this is how many you have left, the percentage that is done. Gives you the binary log and position that it's working on. Where that's actually useful for us is, we're starting to have this a little bit, is if you have disk space stress and you need to kill some binary logs, you want to make sure you don't delete that binary log or anything before after it, because then you're going to be in a bad spot because gh-ost will fail because it can't find the bin log. If you need more specific information, migration status gives you, the sup command does not give you even the table name. If you're running that command, you probably know what's going on, or you just want to know that a migration is running. With the status command, you get all the information you can about the migration. It gets very detailed. It tells you, the max lag, all kinds of different information for that. So with that, there's a bunch of other commands I want to kind of touch on. Nice ratio is if you want to have between each chunk a little bit of time just sleeping, you would go ahead and set that. The max lag milliseconds you can change at any time. So there was a time that we had a migration going that we had milliseconds at about 500, and replication, it was starting to get kind of iffy, so we dropped it down to 300. and you saw an immediate drop of that because this can be done online. Max load, if your threads are running a little bit higher than normal, but you still feel things are okay, you can go ahead and up that, which is nice. Critical load, we had a situation where we were going to do an alter table, just a straight alter table on an empty table, but we didn't want to mess with the existing migration. So we jumped up the critical load just in case something wonky happened with that alter table. We kind of assumed there wasn't going to be a problem, and there didn't end up being one. But just the fact that we could make that change online was really nice. So and then the replicas, and this was a newer chat command because we had a host that we ended up taking out because it was having some kind of hardware problem. Well, Ghost still thought it needed to check on that host. Well, it was checking for replication lag. Well, the box was down. It couldn't do anything. So Ghost was just like, well, I don't know where this host is, so I'm assuming that there's a problem. So I'm just going to throttle. So we were able to change the replicas that we were going to do. A couple more important ones. Throttle is just shut things off, let things just hang out. This is a situation where we're pretty positive that Ghost has not been a problem with any of the load issues on our MySQL servers. But if someone's really just wants to be absolutely certain, we can throttle, things just pause until we resume, and off we go. So the important, so when we're doing this automation with Ghost, the thing that we need to do at the end is we need to do a cutover. Right now, we don't have table migrations that automatically just once the data's finished copying, it just hangs out and waits for someone to say, okay, go ahead and flip the tables around so we have the new table with the new information. So we do that cutover, and that's great. Panic, well, if we're really worried that things are going awry and we just need to stop Ghost, we panic. So in this cutover command, it does actually quite a bit of stuff. This basically does a status here and tells us what's going on. Ultimately, what it's doing is it's doing a really as fast as possible lock on the tables, renaming the Ghost table to the original table name, and then the original table to underscore table name underscore delete. Or in our case, we have the time and date on that file too. So that's the next part. Then the last part is actually there is a ton of stuff going on here. Ultimately, it tells you that the migration is complete, but in this process, it will go through. It will update the PR, say that everything's good to go. Oftentimes, since we have so many migrations going, it's going to be behind, so it does a git pull, gets all that information. It checks the production database against what it thinks it should be, creates the files for that, and then it does a comparison, and then it starts doing its CI jobs. At that point, we're ready to do a merge on the migration. Let's see here. So in the case of the pull request migrations, we do a QME to deploy the PR URL. What that does is that gets us in queue. Basically, what we do right now is we have one person at a time committing to github.com, and that allows us to do some due diligence testing, things like that. So after that, there's waiting, depending on how many people are in the queue. At the very end, when it gets to be your time, you update your branch, you wait for all the builds to complete, and then you do the merge. In the case of schema changes, we just do a merge. We don't deploy the code out first, check our logging system to make sure everything's fine, because ultimately it's just the schema data, and that's what's going to be going on with that. It's just, we feel very confident that that's not going to be a concern. So ultimately after that, you're just, you're doing more pull requests and more merges. This is the whole situation where you are in a situation where right now we're just doing them one after the other, one after the other. Let's see here. So, like I said kind of towards the beginning, we did have some issues with this because we were trying to get to a point where basically we could, automate everything. And what I was trying to do is create a migration scheduler that would take all the information in that reviewed queue that you saw on the ChatOps and put it in a place to where Ghost would just keep running on its own. Well, we ran into some issues because we don't really have an automated way to merge the code. I'm sorry, I said the Ghost runs. So yeah, the automated pull requests were an idea, but because of the way migrations work, and you have these dates with numbers on them, you end up with merge conflicts, unfortunately. And we're coming up with a solution to fix that, but that hasn't hit precedence to be worked on quite yet. So that's where we've kind of gone from there. So I wanted to take a couple seconds to talk about things that I learned from this. My initial idea was very ambitious, and I didn't do a good job of breaking things down into smaller pieces that could be, push out this, push out that, push out this, push out that. So definitely when you have a situation where you're coming up with a bigger project, you definitely want to come up with smaller changes. Ask for help. And this is it's kind of obvious, but it's sometimes hard. I have the personality that I might ask for help once, and then if someone's busy, I'm like, oh, they're busy. I don't want to bug them. I don't want to bother them. It's ultimately, if it's something that you think is worth doing, keep bugging people. They'll eventually they'll help you if you have a compelling case, and they will also if they can't help you, they'll be willing to point you in a direction to get you going. So definitely ask for help. But first, you want to dig in as deep as you can. Do the research. Take the time. Look yourself. See if you can find something, and put in due diligence. So when the people who do help you ask you questions, you're going to be able to answer them. Okay. And and the last thing is you can't automate everything. In our particular case, there are just there are steps that need to be dealt with. I mean, the approvals are very important. People have to look at these migration changes because mistakes can happen. When you're working on something on your own, you can be have blinders and end up messing yourself up because you didn't think of, oh, what about this thing over here that could have that could be affected by the change that you're making. So you want to do that. So the next thing I want to talk about is the opportunities for improvement. Make things more iterative. Make smaller changes, obviously. Some of the automation ideas that I had is, during the approval process, I asked someone about this, and there should be a way when someone clicks approve that there should be able to be a way to run a command that says, okay, well now we actually want to just throw you into the migration add queue. So that should be automatic, so someone wouldn't have to do that. So that eliminates a step. Technically, if it's been approved by our platform data team, 99, probably 999 times out of 1,000, it's good. There's not something that the database team is going to see that says, oh, did you think about this, or was this? So really, we could go ahead and also do the migration schedule part, which gives the commands into the PR to make things simpler for the person who's working on that. So there's that. And the last thing is there's probably some ways that Rails could be changed to where we don't run into those pull request problems. Now, something that I went to a talk yesterday about a tool called Schema, which looks like it could probably solve a lot of these problems that I ran into. I knew about Schema before, but I didn't. I looked at it a little bit, but I was like, it doesn't look like it would probably work for us. But then after talking with Evan, who wrote it, and seeing his presentation, it looks like it's actually probably going to be a really good solution for us to where we can separate the schema migration stuff outside of the Rails application, which would also allow us to set things up to where we could have a queue where the migrations run automatically. And since they're outside of Rails, we don't have the PR headaches that we were having. So, another option for solutions is, come to this conference and listen to a lot of talks. So, ultimately, I got through this a lot quicker than I thought. So, if you have any questions, please throw them out there. Otherwise, thank you. Sorry. One last thing. We are hiring a platform data engineer. If you are interested in that, let me know. We have a couple people from our platform engineering team here, and you can use that link there to check it out.
I'm not flagging because I work with some of it, but I'm also not completely familiar with all the work you've done on this. What do you think are like the major blockers for a fully automated
So the major blockers for fully automating this, Rails has been a big aspect of it. The other thing is, I could probably have gotten to a point where I had used the migration scheduler thing that I talked about to where it would run a migration, but I would have had to have some kind of mechanism to not run the next migration until some kind of OK switch got put on. And ultimately, it seemed like that was going to be a little bit of it was going to be pretty convoluted to figure out how to do that well, because we didn't want to run the migrations on the Hubot box, which is all the Hubot, all those commands, the dot commands that I was talking about. Those are run on that box, so we didn't want to have something run the migration from that box, because that box is busy handling everybody else's Hubot commands. And so there was not an easy way to say, okay, go run this over here. All right, no one else is yelling out, so thank you very much.